Oh, okay. So, yeah. I just need to check if I'm live, if my voice is okay or not. I, hello, I guess my mic, hello. Oh, yeah. So, the video is back. Right. So, this is a fast live stream, and um, sorry, I was just checking something. Sorry. So, hi, my name is Shant, and this is my like first live stream, and I'm just doing this stuff for fun. I don't know, like I just got an idea. Like I, okay, I it's new for me, so I wanna see working. So I guess it will work. So what I want to do is like I am like doing a journey. I wanna be a software developer, and I'm learning. I don't have much of knowledge, yeah, and I'm weak at a lot of things. Seriously, I am weak at even speaking. So this is for the improvement. I wanna improve, and I wanna improve on the YouTube, I guess. So this is like documenting me for fun on a platform. Like I can record my videos in my laptop and then save them, but that will cost me memory. So I thought, why don't I just do it on YouTube for fun? I might not even come live again, ever again. Yeah. So I'm just like doing this for the fun. So even if this video stays on the YouTube, I can like after 1 year or 2 year, I can see myself where I was and where I am. I might go down, I might go up. I never know. So just for the memory, I'm gonna do these live streams, and what I'm gonna do in this live stream is that I will study. I will study with you, or like I think when I teach someone else, I get more knowledge. So I will just learn and then teach on the YouTube. If anyone watches, they wanna learn, they can learn. If no one wants to, that's okay. It's just a journey of me doing stuff. So yeah, I don't know. I might fail. I don't even have any expectations. And uh, as I told before, like I am weak at many things. One is my language. I am not like uh, English. English. Uh, I don't even know the word. Uh, English. My mother tongue is not English, so I might not speak very well, or might not even say things. I don't know. Like I can say things that are not actually like correct as of the dictionary or yeah. So I hope you can understand. This is for the improvement. So I wanna speak English. I wanna learn English, and I wanna like practice it. So yeah, I'm just doing it on the YouTube. It's just for fun, seriously. So, yeah, so I thought like everyone wants to become developer. So I thought, why don't I? I have a much little bit of knowledge about Java, and I created a video. Like I posted a video about my project in the previous video of this. Yeah. So in that project, I use Java as backend and React Native as frontend. So I thought, okay, everyone write code, and why shouldn't I? Yeah, okay, so I will keep it like this. I don't know if this is correct or not. Uh, so everyone write code, and everyone like do coding, and yeah. So why shouldn't I like? learn clean code. Like I heard about this book, Clean Code, and I just wanted to like, yeah, just let's learn how to write a clean code. So I might do this book on the YouTube with you. If I get bored, I might open something new. Like I also want to do typing like practice. So I might even do what should I say? Yeah, typing practice with you. I will change. I just want to learn. So and also like teach you. I don't have enough knowledge. I know, but I just want to do it for the fun. Yeah. So that's yeah. Back to the topic. I am thinking of doing this book, like reading this book, and then reading it online, so that I can save it as a journey. I don't know why I'm repeating myself. I just don't know what I'm actually doing. So I hope you don't mind it. So yeah, I guess we should start this book and let's actually write clean code. And I have to understand this, the use of this, the OBS, yeah, because I want to change something in my description. Actually, I want to add my GitHub link. Like I added two links. One is my LinkedIn, and second is for buy me a coffee. If you want to buy, I don't know why you would buy me because I'm not doing anything crazy. But if you wanna buy, you can buy me. And I didn't check if that link works or not. Yeah, it works. Okay. And yeah, if you go on uh, buy coffee, buy me a coffee, you will see my GitHub page there. Yeah, and then you can uh, see my GitHub profile. I will show you. I don't know if this will work or not. I might even close my, what should I say, stream because I don't want to show something wrong or like bad. It's my first time, so I hope you can understand. Um, I'm opening my GitHub. Just give me a second. I hope this works. I can open it here. I don't know if this will work or not. Yeah. So if you come here, you will see the GitHub, and then you can like open my profile from this, and you can yeah buy me a coffee if you want to. Always your choice. So let's get started with the book. I might yeah. Okay. I need to actually check how the book is showing. Uh, okay. I will. Oh, anyway. Okay. So what I need to do is let's just start reading. This is the part where it's saved. I just don't like to show the path and every other stuff. It's in the video, I know, but it will like make me, what should I say? Like, it will distract me, I guess. I don't know if you can feel that or not. So, yeah, clean code. Let's start writing clean code. If you want to read this, and read, yeah, what will in this book content? Chapter 1 Clean Code. There will be code, a bad word, the cost of owning a mess, okay, the grand design in the sky attitude, the primary I don't know what to say about this word. Don't know. Conundrum, processor. Conundrum, the art of clean code. What is clean code? School of code, CR, author, VR author. Okay, okay, okay. Meaningful names. Okay. The variables name, functions, comments. Okay. I think I need to learn this more because I seriously don't know how to write comments. Like I know the yeah syntax. It's not like I can even use control and then backslash. So, but the language in the comment, like in my project, I wanted to write. I think I wrote something like all a big sentence, like what this function do, how this do, and I actually don't know if I did it right or wrong. Some function even had parameters, so I didn't actually explain the parameters. So for that part, I think I will learn a lot from this. Formatting, okay. Formatting is, I think, not a big issue because there are inbuilt formatters. So you just need to click and format objects and data structures. I don't know what to expect in this. Error handling, okay, this is important. Boundaries, don't know what this is. Wait, boundaries, L log4j. I think log4j is for that error handling and printing. So I know about the log4j, SLF4j. Yeah, it's in the Spring Boot. I did use it. Unit test here, unit test. Yeah, unit test. I know. Unit test here, unit test. Right. Classes. Okay. Blueprints. Yeah. Classes are blueprints. So systems. System. Okay. Dependency injections. Okay. I think dependency injection was an SQL MySQL like when they it was like SQL injection when someone hacks something, yeah, like that. Cross-cutting the procedure. Don't know what is in this. Emergence. I'm bad at pronunciations. Don't expect good things from me. Getting clean. Well, no, I don't know what this is. No duplication. I think this is no duplication can be like that. How to note write same code again and again in different files or in different functions. I think that can be in this one. Concurrency. Why concurrency? Don't know. Successive refinement. Okay. Args implementation. Args JUnit. I have heard about the JUnit. Yes. Let's see. Smell and you tongue twisters. Did it yourself. Okay. So I guess we have a lot of things to learn. Seriously, a lot. It will be fun. Let's start with the. I don't know if this is important or not, but I'm gonna pass. Okay, introduction. Let's see. The only valid measurement of code quality for WTFS per minute. Okay, I think I understand from this line is that if a developer want to, if a developer is reading your code, how many times will he or she will say or other pronouns if you follow them? I don't want to offend anyone. So how many times he or she will say for WTFS per minute? Uh, so good code will be if they say two times, and bad code will be if they say more than two times. Yeah, like WTF, WTF, WTF. Which door represents your code? Which door? represents your team or your company? Why are we in that range? Is this just a normal code review, or have we found a stream of horrible products shortly after going live? Is it talking about me? I'm not a horrible product. Are we debugging in a panic, pouring, pouring our code that we thought worked? Are customers living in droves and managers breathing down on our neck? How can we make sure we wind up behind the right door when the going gets tough? The answer is craftsmanship. Okay, so basically, it's saying that which door represents you, your team, and why are you behind? If you are behind bad code door, why are you there? What can you change, or your team can change to get in this door? And that skill is called craftsmanship. Craftsmanship. There are two parts to learn craftsmanship. Craftsman. Uh, craftsmanship. Okay, craftsmanship. Man, craftsmanship. Okay, knowledge and work. You must gain the knowledge of principles, patterns, practice, and fire rate of words. Hero, heroic sticks. I don't even know, man. I seriously don't know. I'm not joking. Seriously, I need to check it. First, I will. Yeah, will just ask the pronunciation. Say the You can't see that you can't see the other screen because I only set the screen to the OBS to go live. So you won't be able to see that. I know. But what can I do? Craftsmanship. Craftsman.
Heuristic.
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 Hero. Heroistic. 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 What does that mean? Of or relating to a usually relating formulation serving as a guide in the investigation. No, didn't help. Didn't help this much. It's, I don't know why this episode is getting out of my ears. Okay. Sorry. So I'm finding the meaning of hero. Oh, just a sec.
Heuristic.
Hero, heroistic.
Heuristic.
Heroistic. I'm finding the meaning of that word is involving or serving as an aid to learning, discovery, or problem solving by experimental and exception, especially trial and error methods. Uh, I hope you understand because I didn't. That a craftsman that a craftsman knows, and you must alone grind that knowledge into your fingers, eyes, and gut by working hard and practice. Oh, so what? For example, if someone asks you, how can I become? How can I like be a craftsmanship? How can I get that? The simple answer is that you must have the knowledge and the work, and you must do the work. The knowledge is like you know the principle, you know how to write the code, like in that principle or in that language. If I will use the example of Java because I'm little bit mm, I actually know Java, so I will use Java as an example. So do you know the OOPS concepts, object-oriented concepts? Do you know the patterns like the encapsulation, polymorphism? There are two more. Let me think. Encapsulation, polymorphism. One is abstraction, and there is one more. What is it? Uh, Encapsulation, abstraction, polymorphism. No, inheritance? No. Is that? No. That's the. I will give it. I will give the best thing. Four, the four pillars of his in encapsulation. Yeah, I know. Inheritance. Okay, it was inheritance. I thought it was my bad. So it's inheritance. Yeah. So I don't have knowledge. Okay, so I don't have craftsmanship. Wow. I must work hard. The second part is you must work hard to get that knowledge. So that even if someone asks you in like you're speaking sorry you're sleeping and in the middle of the night someone came and asked tell me the concepts of oops, you must tell them at that moment without thinking, just like polymorphism, inheritance, encapsulation, abstraction, polymorphism, that definition, examples, code. You must know everything. Not like everything is like you must know the syntax and syntax. Syntax is not that hard, but yeah, you must know. I think you are understanding my point. Although no one is watching, so I am understanding my point. I can teach you the physics of riding a bicycle. Indeed, the classical mathematics is relatively straightforward with gravity, friction, angular momentum, center of mass, and so forth, can be demonstrated with less than a page full of equations. Given this formula, I could prove to you that bicycle riding is practical and give you all the knowledge you needed to make it work. And you stood for the first time you climbed on that bike. Okay, basically it's trying to say that uh, like I can tell you what you need to do, but you won't be successful in your first go. You will fall. That's the book is saying. I'm not saying to you. You might even do it in first go. That's amazing. You are genius. But the book wants to say that you have to do it. I can tell you everything. I will like give you how to move the pedal. But when you get on that bike, you will fall because you don't know how to balance it. You don't know how to pedal it. So you have to try. That's it. That is what it is saying. Yeah. Coding is no different. Coding is also saying you have to do it. We could write code. We could write down all the feel good principles of clean work, then trust you to the work. You never let you fall down when you get on the bike. But then what kind of teacher will that make us? What kind of student would make that make you? You will be bad student and I will be a bad teacher. No, that's not the way this book is going to work. Okay? Clear boundaries. You will be a good student and I will be the best teacher. Learning to write clean code is hard work. It requires more than just the knowledge of principles and patterns. You must sweat over it, you must practice it yourself and watch yourself. You must watch others practice it and fail. Okay? So you have to watch me and fail. You have to, sorry, you have to watch me getting failed. Not you have to fail. You have to watch me getting failed. So you must see that. But I don't, yeah, you are seeing me there and retrace their steps. You must see them. And, oh, you are actually making me fail even in the speaking. Then agonize, agonize over decision and see the price they pay for making good decisions in the end. I hope this life shift doesn't make me leave it. Be prepared to work hard while reading this book. This is not a feel-good book that you can read on airplane. On an airplane. If you are on an airplane and finish before you land. This book will make you work and work hard. What kind of work will you be doing? You will be reading the book. You will be reading code, lots of code. I actually think reading code is actually more important than writing because you can write this much code, but you can read this much code. This doesn't make any sense. Okay, what my opinion is that the more we read the code, like if I read, I have 10 students, and if I tell them to write code on a simple function like a for loop, no, that will be same syntax. Okay, like a function to get an API request, yeah, that can work. So then my work is to read their code. They will write 10 students. They might have same syntax, they might have different syntax, but when I read, I will know what kind of variables they are using, or like what kind of logic they are using. The main thing you get from reading code is the logic behind everything. So even if they are using a as a key variable, why they are using, and if someone creative like using the correct variable name like API, uh, then R capital camel case API request. So I can ask why are you using. They will tell they know the principles and everything. But the logic, I will understand the logic because someone might use JSON, someone might use XML to retrieve. So I think the main point is that you understand, you get knowledge of lot of logic from reading code. Then you can implement those code, those logics, those logics in your coding. Like when you're gonna make your code or your program, you don't have to find at that moment because you already read that from others before. And yeah, okay. And you will be challenged to think about what's right about that code and what's wrong with it. Yeah. You will be asked to follow along as we take modules apart and put them back together. This will take time and effort, but we think it will be worth it. It will be worth it. We have divided this book into three parts. Okay. The first several chapters describe the principles, patterns, and practice of writing clean code. There is there is quite a bit of code in these chapters. Okay. Yeah, code is fun. Reading code is fun. Actually, writing is also fun. And they will be challenging to read. Oh yeah. Challenge accepted. I hope. I think I will fail. Yeah, that's the point of this. I have to fail. I have to fail. time it's challenging, so let's see who wins. They will prepare you for the second section to come. If you put the book down after reading the first section, good luck to you. Good luck to you. The second part of the book, I think I will try to cover this book, whole book, in the right way. Like, I can read it offline when I am free because uh, I actually like to read, even if I have 5 minutes, I actually like to read the book because this book, I think it's interesting. But what I will do is that I will only read it when I am on a license. Yeah, so that it will be fair for everyone. Oh, I am watching myself, so it will be fair for me. And like, I wanna read it online, so it will be like also like that. That I'm live streaming. I actually did one book on live stream. That will be also fun. I think I'm gonna do it on the live stream, the whole book. Let's see. Not a promise, okay? The second part of the book is harder part. It consists of several cases. Let me see, my voice is coming in. The second part of the book is the harder work. It consists of several case studies of ever-increasing complexity. Each case study is an exercise in cleaning up some code, transforming code that has some problem into code that has few problems. The detail in this section is intense, so you will have to flip back and forth between the narrative and the code listings. So we will have to analyze and understand the code we are working with and walk through our reasoning for making each change we make. Set aside some time because this should take you days. The third part of this book is the pair. So it is a single chapter containing a list of effort, heuristics, and smells gathered while creating the case study. As we walked through and cleaned up the code, the case studies, we documented every reason for our action as a heuristic for smell. We tried to understand our own reaction to the code we were reading and seeing, and worked hard to capture why we felt what we felt and did what we did. That's also the reason why I'm doing live streams, recording myself. I also want to know in future why and how much I changed. The simple reason is I just want to document myself, why I did, how I did. The result is knowledge base that describes the way we think when we write, read, and clean code. This knowledge base is of limited value if you don't do the work carefully. Reading through the case studies in the second part of this book, in those case studies, we have created carefully annotated each change we made with forward reference to heuristic. Heuristic. If I'm pronouncing this word wrong, I'm sorry, but I'm trying my best to learn it, to speak it more. Uh, the word is the word it was from the like fluently. So yeah, I'm trying to speak it more fluently. I hope that one is also right. Keys. Forward references appear in square brackets like this here. This lets you see the context in which those heuristics were applied and written. It is not the heuristic, heuristic themselves that are so valuable. The relationship. It is the relationship between those heuristics and the discrete decision we made while cleaning up the code in the case studies. Okay. To further help you with this anything we have placed a crosshair at the end of the book that shows the patient before every program and you can use it to look for each place where the seven has supplied a series, the first counter, just and skip over the series and you will have a review of another feel good book about writing good software. Uh, if you read fast and hard skip over the case studies, then you will have read yet another feel-good book about writing good software. So we have to cover it from starting to ending. But if you take the time to work through the case studies, you have to do the case studies. I'm actually gonna do the case studies, I think. I'm actually gonna do the whole book, so yeah, following every tiny step, every minute decision. If you put yourself in our place and force yourself to think along the same path, with then you will gain much richer understanding of those principles, patterns, practice, and heuristics. They won't be feel-good knowledge anymore. They will have been ground in your heart. They, sorry, they will have become, they will have become part of you in the same way that a bicycle become an extension of your will when you have mastered how to ride it. So we're gonna make them in our mind, in our over the cover, on the cover, sorry, on the cover. Is it? I guess, I guess, yeah. Let's just read it. The image, how much is it showing you? Will it change the screen? I'm actually like seeing myself in my phone, how the image looking. Oh, oh, it didn't change anything. Oh, okay. The image on the cover is M14 from Peru, from, from Beirut, Lebanon. M104 is located in very, very, very good, very good. Why? Oh, and it's just under 30 million light years from us. As its core is a supermassive black hole weighing in and in at in at about a billion solar masses. Does the image remind you of the explosion of long power moon? Yes. I vividly remember the scene in Star Trek 4, sorry, 6 that showed an inflated wing of the debris flying away from that explosion. Since that time, the explosion has been a common artifact in sci-fi movies. Okay, it's about some movie against both, and so it was even ahead the explosion of Alex not Alan Grant in later edition of the first Star Wars. Okay, Star Wars. So I actually heard about it. I never watched it. I'm not into movies, not even web series. Yeah, not the type I know. What caused this ring to form around Amanpour? Why does it have such a huge central plate and such a bright and tiny middle? It looks to me as with a central hole, lost its cool and blue a 30,000 light year hole in the middle of the galaxy. Void vacuum. Any civilization that might have been in the path of that cosmic dis, dis, uh, disruption, disruption. Supermassive supermassive black holes swallow whole stars for them, converting a sizable fraction of their masses to energy equal to and since there is leverage when n is stellar mass, look at how many stars fell headlong into that mass before the mass was radiated. Could the size of central void be a hint? Sorry, the image of M104 on the cover is a combination of the famous visible light photograph from Hubble sky and the recent infrared image from the space observing the observatory below that. It's infrared image that is this one. This one is more like a stone. Yeah. The infrared image that clearly shows us the ring nature of the galaxy. It's visible light we only see the front edge. The ring is so beautiful, beautiful. The central plate obscures the rest of the ring, but in the infrared, the hot particles in the ring shine through the central plate. The two images combined give us a view we have not seen before, and imply that long ago it was a ring from activity. Okay, this is our first. We are reading this book for two reasons. First, we are a programmer. We are a programmer. I hope you are too. Second, we want to be a better programmer. Definitely. Good. We need better programmers. So it's saying there are a lot of programmers, but industry wants a better programmer who can write clean code. Okay? Yeah, like this. Take your laptop, wash it, then your code becomes clean. That book is not. This is a book about good programming. It is filled with code. We are going to look at code from every different direction. We will look down at it from the top, up at it from the bottom, and throw it from the inside out. By the time we are done, we are going to know a lot about code. What's more, we will be able to tell the difference between good code and bad code. This, I think, this is a good skill. If I had this skill, I might be, I might be lucky, I guess. Oh, okay, so you can't actually see me. Okay, now I get it. Hmm, wow, so you don't see the options when I like that's something. Yeah. Hmm, oh. I was saying like finding a difference between good and bad code is like crazy. You would be like, yeah, if you become an extra, I know, this, then you will be like, now I understand. But then in the coding interview, they say Even if you fail to write the code, they will see the logic. I think they might even see how you are writing the code. Is it good? Is it bad? It might even work in that scenario too. Wow. We will know how to write good code, and we will know how to transform bad code into good one. Good code. There will be code, obviously. One might argue that a book about code is somehow behind the times, that code is no longer the issue, that we should be concerned about models and requirements instead. Indeed, some have suggested that we are close to the end of code, that soon all code will be generated instead of written, but that programmers simply won't be needed because business people will generate code from the specifications themselves. We will never be rid of code because code represents the detail of the requirements at some level. Those details cannot be ignored or abstracted. They have to be specified, and specifying requirements in such detail that a machine can execute them is programming. Such as such a specification is code. Okay, actually we are saying uh, this thing in reality that ChatGPT is doing things, but ChatGPT can try bigger, small code. It can give you function, it can give you loop, but it cannot, as I'm seeing from my knowledge, it might even do like in the paid version or in the other version, but I think it can't write a complete application. And it sometimes, even in small programs, it do some silly mistakes like uh, it might not import things. Then at that time you need little bit of like you do need a programming knowledge, like so that you can find the error in quickly. So that's what this became saying. Code cannot be, or the program cannot be removed. It's needed. I expect that the level of abstraction of our languages will continue to increase. It's increasing. I also expect that the number of domain-specific languages will continue to grow. This will be a good thing, but it will not eliminate code. Indeed, all the specifications written these high level and domain specific language will be code. It will still need to be rigorous, accurate, and so formal and detailed that a machine can understand and execute. The folks who think that code will one day disappear are like mathematicians who hope one day to discover a mathematics that does not have to be formal. They are hoping that one day we will discover a way to create machines that can do what we want rather than what we say. These, uh, like, this is like, yeah, one day we will discover, uh, one day we will discover a way to create a machine that can do what we want rather than what we say. This is like in mind with want. We want that a machine, like, if I have a machine, I think it might teach me. That's what I want. What what does say means what we say is like the code. We say to machine by the typing code. That's that this line is saying that the machine people are hoping that the machine can do what we want, not what we say. But in reality, machine do only what we say. Typing. These machines will have to be these machines will have to be able to understand us so well that they can translate vaguely specified needs into practically executing program that precisely meets these needs. This will never okay, claim this will never happen. Not even humans, with all their institutions and creativity, have been able to create a successful system from the great feeling of their customer duty. If the discipline of requirement specification has taught us anything, it is that well-specified requirements are as formal as code and can act as executable tests of that code. Remember that code is really the language in which we ultimately express the requirements. We may, we may create languages that are closer to the requirements. We may, we may create tools that help us phrase and assemble these requirements into formats. But we will never eliminate necessary precision, so there will always be code and good code. The topic is bad, okay, bad. I was recently reading the preface to Kent Beck's book, Implementation Patterns. And he says, this book is based on rather fragile premise that could code better. Fragile premise? I disagree. I think that premise is one of the most robust, spotted and overloaded of all the premises in our class, and I think can know it. We know good code matters because we have had to deal for so long with it. Okay, so basically, good code matters. You need to know how to write code, good code, not just code, good code. I know one company that in the late 80s wrote a killer app. You know, it was very popular. I think it's not the name. It's like yeah, which is performing well. I think the killer is in that version. But it might actually be a name of that. It was very popular. It's very popular, and lots of professionals bought and used it. But then the release cycle began. Scratch, scratch. Bugs were not repaired from one release to the next. Load times grew, crashes increased. I remember the day I shut the product down in frustration and never used it again. The company went out of business in short time after that. There was an app, a killer app, like it was performing so well, every professional was using it. The issue in that app was that it was taking a lot of time to load. It crashes like first you have to wait a lot of time. This much, like 10 seconds or like 1 minute load, and then when it's load, it crashes. How will you feel? Bad. That's the author is saying that he used it, it crashed, and he never used it again. 2 decades later, and the company went out of business. Obviously, no one wants to use that crashes like you. 2 decades later, and Matt, one of the early employees of that company, oh, had asked him what had happened. Transfer confirmed by fear. They had rushed the product to market and they had made a huge mess in the code. As they added more and more features, the code got worse and worse until they simply could not manage it any longer. It was bad for the company. Can you even imagine a company, for example, a XYZ company, which is like currently in billions, uh, has a market value of billions of dollars. and then it starts, the app of that company started breaking down, and when it goes out just because of the code. Like, I know it happens when even a single dot is misplaced in a deeper calculation. It happens, and that thing is called bad code. Someone did bad coding there. Someone didn't test it. Someone didn't recheck. Yeah, maybe it covers some testing, but or someone didn't like from my side. I didn't, but my seniors didn't do their job, and this this process makes the company go bankrupt. That's what they are saying. Like a single dot can make company lose. So yeah, have you ever been significantly impacted by bad code? If you're a programmer of any experience, then you have felt this impediment, impediment many times. Indeed, we have a name for it. We call it bag, 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 wedding. No, no, not wedding. Bag, wedding, wedding, wedding. Let me see.
Wade.
Wait, wedding, wedding, wait, wedding. To start, I guess for how we call it, maybe like bit trouble or like big challenge. We wait through bad code. Oh, sorry. I used, yeah. So as I told, I'm not like I mother tongue is not English. So might slip my time into my other tongue. So I hope you can ignore that part because yeah, I'm not fluent. Sorry, sorry about that. Yeah, we wait. We moved through bad code. Yeah, it can be said we moved here. We went through bad code. Yeah. We sloped through a maze of tangled brambles and hidden pitfalls. We struggle to find our way, hoping for some hint, some clue. Oh, what is going on? But all we see is more and more senseless. Oh, yeah. I have to give an example on this thing. Is like you are asked to make a factorial function, okay? But can you make a function that just asks the user? Okay, there is actually a simple function. You have to just do a simple function. If you ask the user to give the value, okay, then you make a function to store that value. Then you make a function to call another function, and then from that function you pass the value. Yeah, so even when understanding, it's like crazy. My, I'm trying to say this function. Okay. First function pass the value. Second function stores the value. Third function, from this function we call this function, and it the job is of this function is to check the value. Then it calls another function to the factorial function. Then that factorial function do a recursive function. Okay, I hope you know the recursive. Like recursive is like if, for example, the function a function name is factorial. Okay, let's assume. So the return statement or the statement will the function will call itself in the return statement. Function will call until a certain condition is met. So that's a recursive. It is used in factorial when we have small number because when we go at higher number, then the function will call again, call again. It might even break the stack. It might, yeah, we can say it will overflow the stack. Stack is a memory. Uh, in the JVM and JVM stack heap, and there is method memory. There are two other memories that are node. So like common, yeah, the main is stack heap and method memory. Yeah. So the basic thing, you are using these many functions, and then you will have the company. You made this program. Program was so simple that you just needed to make a factorial function. But you need like three or four or even five functions, and good programmer, which know good code, come and tries to do it. Define what the mess is. It's like why there is senseless code. Why this person, the previous person, made so many functions when only one or two. For example, if you want to call the scanner from a function, then you can, yeah, do. When there was need of two functions, this person need five functions. It's just like this is senseless, right? So that's what they're trying to say. That don't write senseless things. Don't write senseless code. It's not helping us. No, not even yourself. You are not learning anything from it. You will say, yeah, I'm learning how to code one function from another. Okay, of course you, have been implemented by that code. Okay, yeah. So then, why did you write it? Why did you write it? And why did you write it in the development of this app for the program? Were you trying to go fast? Obviously, no. Were you in a rush? Probably so. Perhaps you felt that you didn't have time to do a good job. That your boss would be angry with you if you took the time to clean up your book. Oh, this line. My approach is also kind of like robust. We can say force, brute, brute, brute. I actually do two types of approach. One is like detailed. When I write code, uh, I have a planned approach. What I do is like I make plans of what function I will have in my code. They might increase, obviously. I think most of the time I might increase one or two functions when I take that approach because when I write code, I actually get more scenarios. First, I think about for example, if you have to make a class of student in Java, I will give example in Java. So if you have to make a class of student, then you think, yeah, okay, we will make a class. It will be a public class. It will be private. We will have ID, student name, and a phone number or email for things private. Then getter and setters. Then, oh yes, that was for example thinking. Then we start to write. If you are using Spring Boot, you just need to add annotation data. Yeah, I know. But if you are using just Java, then you write, and then you remember. Okay, what if a user want to get complete information of the student? Then you like, yeah, I didn't think of that in the starting, but now, okay, if a user wants the complete information like student name and everything, he will say, okay, they will call getters of every. But the better approach will be override the toString method. Yeah, you can override the toString method, and then for just calling that method, you can get the complete information You can add more things in a toString method. That's on the need. That's what I'm saying. The, the first approach is planned, but you can change a little bit in like future. But if you have different classes, a lot of classes, then change will like affect others other than others. Yeah, but there will be changes as far as I have experienced. But in brute force, and the second approach is brute force. Okay, you have to make it student class. That's it. Start writing. You like okay, public class student, student first name, last name, email. Okay. Now, now what should I do? They will want a name. Okay, right, and then you will okay done. The brute force same. But brute force, okay, this was not a good example of brute force. Good example will be like um, a big program. Okay, yeah, factorial one. Factorial one is good example because you have to write factorial, and then you thought that I will use recursion. Then you wrote the code. Okay, you did make the condition that you have to write a factorial code, but then you think, is it actually a good code? Is it like what will happen when a large number is there? It will actually take time. It will like be not good for the customer. Then you okay. The approach is good because I am calling like the number is getting subtracted every time it's called. So why don't I subtract it in a loop? Like recursion is also kind of loop. Why don't I just directly make a loop? You can do that. Then you like think on your robust on your uh, the brute force attempt, and then you try to improve that code. So that's the cleanup. The example was I don't know if one was confusing or not, but I hope you understand. Perhaps you were just tired of working in this program and wanted it to be over, or maybe yeah, or maybe you looked at the backlog of other stuff that you had stolen from it to get done and realized that you needed to slam this module together so you could move on the next one. We all have done it. So we all looked at the mess. Uh, uh, I am thinking of something I will tell it after this. We all have looked at the mess we have just made and then have chosen, chosen to leave it for another. We all sat the relief of seeing our messy program work and deciding that a fucking mess is better than nothing. We all said we go back and clean it up later. Of course, in those days we didn't know. Leave life, later equals never. So if you don't clean the program at the same moment, or if you don't clean that at the same moment, you will never change it. That's the book says. So, from the point I was thinking is that I told you the two project. What I think you should do is like you can also do the same. I think you should go or you can find even yours. You can be like, okay, I know the structure. I thought of the structure, you write the structure, but then you don't know what to do. But you just just start writing. Then you do, then you can improve. You can take any way, but I think you should uh, go. You should like take a particular. Yeah, there is no need for particular. Then you do. Can write code. Good code. That's it. Like my point was that uh, you can like view out my example, then you can decide what you actually want to do. That was what I was trying to say. So do what fits on you if you're doing it alone. The cost of owning mess. What's the cost? If you made the mess, you have to own it because you did it. If I'm matching the YouTube from my video, so it's my mess, not YouTube fault, so not your fault that I'm using YouTube. It's my fault. Right? If you have been a programmer for more than 2 or 3 years, you have probably been significantly slowed down by someone else's messy code. Okay. If you have been programmer for longer than 2 or 3 years, you have probably been slowed down by messy code. The degree of slowdown can be significant. Over the span of a year or two, teams that were moving very fast at the beginning of of a project can find themselves moving at the snail's every chance they make to the code breaks two or three other parts of the code. No change is trivial. Every addition or modification to the system requires that the tangles, twists, and nodes be understood so that more tangles, twists, and nodes can be added. All the time, the mess becomes so big and so deep and so dark, so they cannot clean it up. There is no way at all. If you remember in the start, the company also got down or bankrupt because of this. They were moving very fast from this example we can assume the team was moving very fast. They rushed a lot. Then the mass increased, and then broke. As the mass builds, the productivity of the team continues to decrease. Is I actually need to see.
Asymptote.
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 Asymptotically. So, a straight line of very about that. Oh, optically approaching zero. So, as productivity decreases, now management does the only thing they can. They add more stuff to the project in hopes of increasing productivity, but then more stuff is not worked in the design of the system. They don't know the difference between a change that matches the design intent and a change that throws the design intent. Furthermore, they and everyone else on the team are under horrific pressure to increase productivity, so they all make more and more mess, driving productivity and forward towards the zero. Okay, let's try to understand it from the graph. Oh, now you can see it. This is productivity. This is time. It's saying as the time starting, we have 100% productivity. As the time goes, the mass increases. As the time goes, mass increases. And then the time goes on and productivity decreases. And eventually it will go to zero. Zero. The grand redesign in the sky. Eventually the team rebels. They inform management that they cannot continue to develop in this obvious process. They demand a redesign. Management does not want to expend the resource on a whole new redesign of the project, but they cannot deny that the productivity is powerful. Eventually, they bend to the demands of the developer and authorize the grand redesign in the sky. Okay, what they are saying? First, we design the program. Productivity started to go down. Now they are again trying to redesign that. So what is it showing that how you didn't spend that time more slow, You are going slow. They are doing the same thing again. How you are trying to do one thing and again. And how about a single thing more time? It will like the sing if you're writing this code two times. If you're writing this code only one times, but with more careness, with more like thought, thinking, then obviously one times will be more code, right? And writing two times same code is like no, it doesn't it doesn't give you good feeling also because you didn't get rewarded for your first program. You feel like yeah, it was a mess. You get I think I didn't experience it, but I think that it might even depress or like it can motivate them low. It gives them low motivation. That's not good. Yeah, I hope like it will decrease their motivation. New trigger team is selected. Okay, everyone wants to be on this team because it's green field. So they start to work out to do something truly good. But only the best and brightest are chosen for the tiger team. Everyone else must continue to maintain the current system. Now two teams are in this big mess. The tiger team must build a new system that does everything that the old system does. So, not only that, they have to keep up with the changes and that are continuously being made to the old system. Management will not replace the old system until the new system can do everything the old system does. The race can go on for a very long time. I have seen it take 10 years, and by the time it's done, the original members of the team are long gone. The current members are demanding that the new system can be designed because it's such a if you have experienced even one small part of the story I just told you, then you are always either spending time keeping a record clean is not just questioning its matter of aspects. Right? Yes. So this is like recursive. I'm giving recursive so many times. For example, here record wrong, new code wrong, new code wrong. It's like oh, sorry, in circular attitude. Give more time, but try to control. Have you ever wanted to wait so a nice so great that it took weeks to do what should have taken hours? Yeah, bad. Have you seen what should have been a long line? One line, sorry. Have been a one line change made instead in hundreds of different modules? Two symptoms are too poor. Why does this happen? Why does this happen to code? Why does good code grow so quickly into bad code? We have lots of explanations for it. We complain that the requirement change in ways that throw the original design away. We being the struggles that get tied to do things right. We feel heard about durable bookkeep managers and intolerant intolerant customers and useless marketing types, Dell phone sanitize. Yes, for the fourth, yes, Dell is not in our style, but in ourselves. We are unprofessionals. We are unprofessional. This may be a better pill to swallow. How should this match be coded? What about the requirement? What about the schedule? What about the schedule managers and the user marketing types? Shouldn't there be some kind of flow? No. The manager and marketers look to us for the information they needed to make promise and commitment. And even when they don't look to us, we should not be shy about telling them what we think. The users look to us, validate their requirement will fit into the system. The project manager look to us to help work out the schedule. We are deeply com- complex in the planning of the project and share a great deal of responsibility for any failure. Exception. Those failures have to do with the bad code, with the bad fit usage. If I don't do what my manager says, I will be fired. Probably not. Most managers want the truth, even when they don't act like it. Most managers want good code, even when they are stressing about the schedule. They may defend the schedule and requirements with passion, but that's their job. Yeah, it's your job to defend the code with equal passion. So, oh, I'm sorry, you will not able to see it. I think you can say I forgot actually. I was not able to see it. So, okay, I will explain it. If this line is saying, okay, the manager will say, the schedule can't change. You have to do it because that's their job. They have to tell their employees, their juniors, that you have to do it. But it's our coders, programmers' job. That if you tell, force us to do it, it's not the same wording. You can't say like, if you're forcing, they're not forcing, they're paying you to do it. You have to do it. You just leave the job. But if they tell us to do it in that type of way, you can say, okay, I will do it. My team will do it. But the code will be bad. And if the code is bad, the more resources will be gone. And this will be a bad and big problem for all of us. So why don't you give us some extra time so that we can plan more or we can do it a better job? I think you will be more uh, like happy with the results if you take some more time of increase some more time. Yeah, increase the time. That's our job to defend our code. Yeah, that's this lines are saying. That's the manager job is to force you or to tell you what to do, and then you have to tell them they want a good code. No, to drive this point home. But if you were a doctor and had a patient who demanded that you stop all the silly hand washing in preparation for the surgery because it was taking too much time. Okay, from this part, without reading further. I can say, yeah, okay, as far as I know, doctors have to wash their hands because bacteria can kill that patient. But if that doctor listens to the patient who doesn't have the knowledge of the surgery, it will be harmful for that patient. What does this mean? Clearly, the patient is supposed to get pain, that the doctor should absolutely refuse to complete. Why? Because the doctor knows more than the patient about the risk of disease and infection. So we know the risk of the bad cold. It would be unprofessional, never mind criminal, right, for the doctor to comply with the patient. So too, it is unprofessional for the programmer to bend to the will of managers who don't understand the risk of making mess. Hope you understand. The penal conundrum. Programmers face basic control of basic values. All developers with more than a few years of experience know that previous messages slow them down. Yet all the developers feel the pressure to make messages in order to make the long version. In short, they don't take the time to go fast. The professionals know that the second part of the conundrum is when you will not make the deadline by making that days. A mess will slow you down instantly and will force you to miss the deadline. The only way to make it is like the only way to go is to keep the code as clean as possible at all the time. If you want to do your work fast, do it clean. That's I mean the art of clean code. Let's say you believe that messy code is significant in the allow me 1 second.
Impediment.
Im-
Impediment.
impediment. Impediment.
Impediment.
Impediment.
Impediment.
Impediment.
Impediment.
Impediment. Impediment. Hindrance. Hindrance. Yeah, we can say hindrance. Significant hindrance. Impediment. Let's say that you accept that the only way to go fast is to keep your code clean. Then you must ask yourself, how do I write clean code? It's not good trying to write clean code if you don't know what it means for a code to be clean. Okay, bad news is that writing clean code is a lot like painting a picture. Most of us know when a picture is painted, well or badly. Okay. But being able to recognize good art from bad does not mean that we know how to paint. Okay. So, to being able to recognize clean code from dirty code does not mean that we know how to write clean code. I think this line is deep. If I take it on myself, I can see who wrote the bad code, but I can't actually know how to write clean code. I actually don't know. That's why I'm reading this. When uh, suppose the cost of owning it, when will the code stop? I'm just telling nothing. This part doesn't have. I think second will have. The total cost of earning a Mac. I think clean code requires discipline. Uh, so, writing clean code requires discipline. User might is literally let me see.
Myriad.
Maybe writing clean code requires the discipline use of a maybe little techniques apply. Threads, wow,
Painstaking.
painstaking, taking, painstaking,
Painstakingly.
painstaking. Requires sense of cleanness. The code sense is the key. Some of us, some of us are born with it. Some of us have to fight to acquire it. Not only does it help us see whether code is good or bad, but it also shows us the strategy for applying our discipline to transform bad code into clean. A programmer without code sense can look at a messy module and recognize the mess but will have no idea what to do about it. A programmer with code sense will look at messy module and see options and very the code sense will help the programmer choose the best solution and guide him or her to explore the sequence of behavior, preserving transformation to get from here to there. In short, a programmer who writes clean code is an artist who can take a blank slate through a series of transformations until it is an elegantly flowed system. What is clean code? There are probably as many definitions as there are programmers. So I asked some very more and deeply experienced programmers what they think. So this person is a programmer. I will not pronounce the name because I don't wanna disrespect the inventor of C plus over the no, respect. I feel like my code to be elegant and efficient. Logic should be straightforward to make it hard for bugs to hide. The dependency minimum to ease maintenance, error-handling complete according to an articulated strategy, and peak performance close to optimal so as not to tempt people to make the code messy and with unprincipled optimization. Clean code does one thing well. Browsing use the word elegant. That's quite a word. Dictionary in my MacBook provides the following definition: pleasingly, graceful and stylish in appearance of ornament, pleasingly, endurance and people. Notice the emphasis on the word pleasing. Pleasing found apparently sorry sorry uh Berger thinks clean code is pleasing to read. Reading it should make you smile the way a well-crafted music box of or well-designed graph would. I didn't want to use it. I didn't want to say the name again and again. But that's the truth. Like, the reason I didn't say it in the first place because I know how I will not pronounce, pronounce it right and as a respectful programmer they didn't want to disrespect them and anything. But so, which I'm trying. Uh, Bridgend also mentioned efficiency twice. Perhaps this should not surprise us coming from the inventor of C++. But I think there's more to it than the sheer desire for the speed. For speed. Wasted cycles are inalienable, they are not pleasing, and now note that the word that Bayesian uses to describe the consequences of that elegance, he used the word there is a deep truth here. That code wants the mesh to grow. When others change that code, they tend to make it worse. para- pragmatic Dave Thomas and Andy Fast said this is a different way. They used metaphor of broken windows. A building with broken windows look like nobody cares about it, so the people stop caring. They always know windows become broken. Eventually they will break them. They whisper, hey, fake, fake
Facade.
facade. They spoil the facade with drifting and allow causes to select. One broken window starts the process twice decay. We can also mention that apparently should be complete. This goes to the discipline, discipline, sorry, discipline of paying attention to details. Abbreviated error handling is just one way that programmers gloss over it. Memory leaks are another. Race conditions still another. Inconsistent naming, inconsistent naming yet another. The upshot is that clean code exhibits close attention to details. The origin also closes with the assertion that clean code does one thing well. It's no accident that uh, that there are so many principles of software design that can be boiled down to this simple admonition. Writer after writer has tried to communicate this. By default tries to do it too much. It has modeled intent and executive of purpose. Clean code is focused. Each function, each class, each module exposes a single-minded attitude that remains entirely unrestricted and unpolited by sound in detail. Feel like clean code is focused. Mm, Trying to see the next. Author of object-oriented analyze and design application. Clean code is simple, direct. Clean code reads like a living code. Clean code is clean code never obscures the designer intent, but rather is full of strict instructions and fixed lines of control. Grant makes some of the points as well, but he takes a readability perspective. I especially like his view that clean code should read like well-written code. Think back to a really good book that you have read. Like this book is really good. Remember how the word disappeared to be replaced by the by images. It was like watching a movie, wasn't it? Better, you heard the characters, you heard the sound, the experience of what this makes.
Pathos.
Ethos, pathos, emotional, emotional sympathy, sympathetic, uh, the humor. Reading clean code will never be quite like reading load of brain. Still, literal metaphor is not a bad like a good novel. Clean code should clearly expose the tension in the problem to resolve. It should build to tension to a climax and then give the reader that, oh, of course, as the issue and tensions are resolved in the resolution of an obvious solution. I find Reddy's use of phrase script exception to be fascinating symbol. After all, the word "crypts" is merely a synonym for the for concrete, and MacBook's dictionary holds the following definition of crypt: "Briskly deceive, matter of fact, is doubt, hesitation, or unnecessary detail." Despite this seeming, why there are so many like I guess I don't actually know about the
Juxtaposition.
juxtaposition of meaning. It does the act of an instance of placing two or more things side by side often to compare or contrast and create an interesting effect. Okay. Despite this same juxtaposition of meaning, like comparing two meanings, yeah, the words carry a powerful message. For our code should be matter of fact as opposed to speculative, speculative,
Speculative.
speculative, based involving speculative. It should contain only what is necessary. Our reader should receive us to have in this Greek founder of OTI, godfather of Eclipse strategy. Eclipse is also an idea. Think of can be can be read and enhanced by a developer other than its original author. It has it has unique and ex, ex, wow, acceptance tags. It has meaningful names. It provides one way rather than many ways for doing one thing. It has minimal dependencies which are explicitly defined and provides a clear and minimal API. Code should literate since depending on language, not all necessary information can be expressed clearly in code alone. Big Dave shares Brady's desire for readability, but with an important thing. Dave asserts that clean code makes it easy for other people to manage it. They may seem obvious, but it can be over
Overemphasize.
overemphasized, not to be overemphasized. There is a whole difference between code that is easy to read and code that is easy to change. The size famous because 10 years ago, 10 years ago, this would have raised a lot of eyebrows, but the discipline of test-driven development has made a profound impact upon our industry and has become one of our most fundamental disciplines. There is right. Code without test is not code. No matter how elegant it is, no matter how readable and accessible, it has no text. It be ugly. Dave uses the word minimal twice. Apparently, apparently, he values code that is small rather than code that is large. Indeed, indeed, this has been common preference for software literature since its inception. Small is better. Okay. Dave also says that code should be literate. This is software reference to Knuth's literate programming. The upshot is that code should be composed in such form has to make it readable by humans. Okay, about talk more about doing something else. Uh, okay, I'm taking a break, kind of like I'm doing something with the string. I'm trying to figure out some things. So, you wanna go somewhere? I'm taking a break, trying to figure out something else. Yeah. Did I do something? Oh, no. Oh, yeah, I read it. So I actually am trying to figure out is live chat option in this. I'm trying to like shift windows and switch windows. Sorry. Oh, if there is one issue, I have to talk about that. Yes, there is live or chat option because I can't see it. You know, if you are watching, like if someone is watching you, can they like type? Or can they like click on the like? Or if they can remove the like? Because I don't know if the chat option is available or not. I'm actually trying to have that option, but I can't find it because this is my first game and I don't know where to find. And it's also kind of left for my life. Yeah. What is stream by rate? Because mine is saying low and I have to increase it. So I need to check that too. Like what is stream by rate? Mm-hmm. Let's see what else I have to do. I will say it later, I guess. Uh, Let's just continue. Author of working effectively with legacy code. I could list all the qualities that I noticed in teamwork, but there is one overarching quality that leads to all of that. Clean code always looks like it was written by someone who cares. There is nothing obvious that you can do to make it better. All of those things was code about the code so tough. And if you try to imagine improvements will lead back to where you are, then appreciation of what code someone does for you was left by someone who cares deeply about the craft. One more, care. That's really the topic of this book. Perhaps an appropriate subtitle, How to Care for Code. Like laid it on the head. Clean code is code that has been taken care of. Someone has taken time to keep it simple and orderly. They have paid appropriate attention to details. They have cared. Install the author of Extreme Programming installed an Extreme Programming Advanced begins Shark. Ron began his career programming full-time at Strategic Air Command and has written code in almost every language on and almost every machine. It pays to consider his words carefully. In recent years, I began and nearly end with tax rules of simple code. I pri- in priority order. Simply code. Runs all the tests, contains no duplication, express all the design ideas that are in the system, minimize the number of entries such as classes, methods, entities, entries, methods, functions, and the lack of these. I focus mostly on duplication. Actually, this is hard because I also use duplication. Like I I created two requests. So, for example, if I request uh, in different APIs requests, like I'm sending to a server and they're returning it, but this much line. For example, I have 10 lines and then 4 lines in 5 functions are same. And I know duplication is bad, but like trying to understand how to remove it is also hard. So that actually, like, if you know how to remove duplication, well, actually, if you know everything, that's awesome. But yeah, I have faced duplication, and I actually couldn't remove it. So I need to understand these topics like this because it's it is good because this wording it actually is relating to me. So, with duplication, so of course I focus mostly on duplication. It actually is important for me. Like I have experienced, as I told, when the same thing is done over and over, it's a sign that there is an idea in our mind that is not well represented in the code. True. When you actually write code and face these challenges, you will know, yeah, this line is actually true. I try to figure out what it is. Then I try to express that idea more clearly. I guess I wasn't able to like think more creatively in that part. Uh, Expressiveness to me includes many full names, and I'm likely to change the names of things several times before asserting. With modern coding tools such as Eclipse, renaming is quite easy. expensive, so it doesn't trouble me. That's the change. Expressive goes beyond names. However, I, is it in the Bayesian? Oh no, sorry. Where, oh, no, I hope it is in beyond names. However, I look at whether an object or method is doing more than one thing. If it's an object, probably needs to be broken into two or more objects. If it is a method, I will always use the abstract method to repeat things on it, resulting in one method that says than more clearly what it does, and some method saying how it is done. Duplication and expressiveness takes take me a very long way into what I consider clean code and improving dirty code. With just these two things in mind can make a huge difference. There is, however, one more thing that I am aware of doing, which is a bit harder to explain. After years of doing this work, it seems to me that all programs are made up of very similar elements. One example is finding things in a collection, whether we have a database or employee record or a hash map of keys and values or an array of items of some kind. We often find ourselves waiting. Sorry, we often find ourselves waiting a particular item for that collection. When I find that happening, I will often grab the particular implementation in more abstract method, okay, or a class that, that gives me a couple of interesting advantages. Abstract method. I hope you know it. It's like a method. Sorry, not a method. Like abstract can be class, can be methods. How can I explain it? I guess I myself don't know it much. Yeah, not googling. I guess. Well, actually, googling is not even bad. Right? Abstract class. I can like tell you about abstract class. Like abstract class as methods that actually are, I can say, not does not have body. Let me correct myself from the Google. Like as far as I remember, they don't have the body. They just have the function name, the type, and just like in the interface, we only define the function. We don't give it body. When a class overrides it, it has to override all the abstract methods. And when a class implements an interface, it also has to override all the methods. Leave the static ones. But let me see if abstract method or abstract class does the same class. As far as I know, it does, but I don't want to give you wrong knowledge. Yeah, it cannot initiate. Yeah, I know. That's fine. Yeah. So you have function uh, that doesn't have a body. Only the overriding class will have its body or have its structure. So what you have, I can implement the functionality now with something simple. So say hash name. But since now all the references to that search are covered by a little abstraction, I can change the implementation at any time I want. I can go forward quickly while preserving my ability to change later. Yeah, in addition. The collection of such often holds my attention to what's really going on and keeps me from running down the path of implementing expectory collection behavior when all I really need is a few very simple ways to finding what I want. Reduce duplication, high expressiveness, and early building of simple instructions. That is what makes clean code fun. Here is a few short paragraphs. Ron has summarized the content of his book. No duplication, one thing, expressing as tiny expression, writing in the inventor of wiki, inventor of co-inventor of e-string programming, motive force behind designing that small talk and OO thought leader, the godfather of all these repair and code. You know you are working on team when each routine you read turns out to be pretty much what you expected. You code it beautifully when the code also make it look like the language was made for the code. Statements like this are practice of what you read it, nod your head, and then go on to the next topic. It sounds so reasonable, so obvious, but it's really registered as something profound. You might think it was pretty much what you expected. Literally. I just thought, yeah, wow. Let's take a closer look. Pretty much what you expected. When was the last time you saw a module that was pretty much what you expected? Isn't it more likely that the modules you look at will puzzling, complicated, tangled? Isn't misdirection the rule? Aren't you used to failing about trying to grab and hold the threads of reasoning that spew forth from the whole system and weave their way through the module you are reading? When was the last time you read through some code and nodded your head the way you might have nodded your head at first reading? Ward expects that when you read clean code you won't be surprised at all. Indeed, you won't even expend much effort. You will read it and it will be pretty much what you expected. It will be obvious, simply and complying. Each module will set the stage for the next. Each tells you how the next will be written. Programs that blend so profoundly well written that you don't even notice it. The designer makes it look ridiculously simple like an exceptional design. And what does Ward notation of beauty? We all have railed against the fact that our languages weren't designed for our problems. But Ward's statement puts the on factor on us. He says that beautiful code make the language look like it was made for the pro. So it's our responsibility to make the language look simple. Language with code everywhere, beware. It is not the language that makes programmer appear simple. It is programmer that makes the language appear simple. Okay? So it's like uh, what I learned is that Bard is trying to say that you should write a code that is like, okay, yeah, I know it will be like this way. I expected it to be like this. So that's what you should do with your code. That's what the word is trying to say. School of thought. What about you, Uncle Pope? What do I think clean code is? That this book will tell you in great detail what I and my compatriots think about clean code. We will tell you what we think makes a clean code, clean variable name, a clean function, a clean class, etc. We will present these opinions as absolute. will not apologize, apologize for our strangers. To us, this point in our career. They are absolute. They are our school of thought about things. Martial arts is do not agree do not all agree about the best martial art or the best technique within a martial art. Often martial artists will form their own schools of thought and gather students to learn from them. So, see, Gary Jiu-Jitsu, founded and taught by Grace family in Brazil. BC Haiku Jiu-Jitsu, Jitsu, I guess, founded and taught by Kami Rai in Tokyo. BC Jeet Kune Do, founded and taught by Bruce Lee in the United States. Some of these approaches immerse themselves in technique teachings of the founder. They dedicate themselves to learn what particular master teaches, often to exclusion of any other master teacher. Later, as the students grow in their art, they may become the friend of a different master so they can broaden their knowledge and practice. Some eventually go to refine their skills, discovering new techniques, and founding their own school. None of these different schools are absolutely right, yet within a particular school we act as though the teaching and techniques are right. After all, there is a right way to practice Raikuji or Jeet Kune Do. But this rightness within a school does not invalidate the teachings of different schools. Consider this book a description of the object mentor school of teamwork, technique, and the teaching and teachings wherein are the way we practice our art. We are willing to claim that if you follow these techniques, you will enjoy the benefits that we have enjoyed, and you will learn to write that is clean and professional. So don't make the mistake of thinking that we are somehow right in any absolute sense. There are other schools and other masters that have just as much claim to professionalism as we. It would behoove you to learn from them as well. Indeed, many of the recommendations in this book are controversial. You will probably not agree with all of them. You might violently disagree with some of them. That's fine. You can't claim final authority. On the other hand, the recommendations in this book are things that we have thought long and hard about. We have learned them through decades of experience and repeated trial and error. Whether you agree or disagree, it would be shame if you did not see it and respect our point of view. We are authors. The author field of Java tell us who we are. We are authors. And thing about authors is that they have read us. Indeed, authors are responsible for communicating well with their readers. The next time you write a line of code, remember you are an author, writing for a reader who will judge your efforts. You might ask, how is the code really? Doesn't most of the effort go into writing? Have you ever played back at the edit session in 80s and 90s? We had editors like Anna that could back of average people you would know about for an hour, then play, play back to your whole edit session like a high-speed movie. When I did this, the results were fascinating. The vast majority of the playtime was scrolling and navigating to others' modules. For when the module was closed down due to functioning to he pauses, considering his options, or he's scrolling up to the top. The module initialization of a variable now his scroll set on to begin the type. Oops, he's erasing what he typed. Types again, he erases it again. It asks for something else, then erases it, scrolls down and he scrolls back, types. You get the book. Indeed, the ratio time spent reading versus writing is well over 10 to 1. You are constantly reading old code as part of effort to write it because the ratio is so high. We want to be, we want the reading of the code to be easy, even if it makes writing hard. Of course, there is no way to write code without reading it. So making it easy to read actually makes it easier to write. There is no escape from this logic. You cannot write code if you cannot read the surrounding code. Code you're trying to write today will be hard or easy depending on how hard or easy the surrounding code is to read. So if you want to go fast, you want to get done quickly. If you want your code to be easy to write, make it easier to read. The Boy Scout. I think I'm just kidding, but I think it's not that hard to understand what this book is trying to say. Like reading and writing does take time, but writing takes more time. But to write a code, you have to know what you have written previously, so you go read. But the code you previously written is bad, so it will take more time to read that code. So more like above, then you will be like go above, you will reach the above. So that will increase your reading time, and then you have to understand the logic again. Then write, then again you have to do the whole process. So the book is saying instead of like even though the ratio is 10 to 1, uh, the reading for the reading versus writing is 10 to 1. Like when you read 10 words, you write 1 word, for example that. Then even when your time will increase for the reading, think about how much time will it increase for your writing. So the book is saying that if, if you write good code, it will decrease your time for reading and it will also like increase time for writing. For example, yeah, that so that's what they are saying. I hope you understand the Boy Scout. It's not enough to write the code well. The code has to be kept clean all the time. We all have seen code errors and degraded as the time passes. So we must take an active role in preventing this degradation. The Boy Scouts of America have a simple rule that we can apply to our profession. Leave the campground cleaner that you found it. If all the checks in our code it is little cleaner than when we check it out, the code simply pulled out. The clean code doesn't have to be something big. Change one variable name to for the better one. Break up one function that's a little bit out. Eliminate one small bit of duplication. Clean up the composite with statement. Can you imagine working on a project where the code simply got better the time passed? Do you believe that any other option is professional? Indeed, continuous improvement and interesting part of professionalism. Uh, uh, this, this is the last page. Ritual and principles in many ways. This book is prequel to a book I wrote in 2002 entitled Agile Software Development Principle Patterns and Practice (PPP). The PPP book concerns itself with principle of object-oriented design. many of practice use professionally developed. If you have not read PPT, then you may have may find that it's continuous story told by this book. If you have already read it, then you will find many sentiments of that book and coded in this one at the level of code. In this book, you will find the code reference to various principles of design. These include the single responsibility, open source principles, interdependency, innovation principle, among others. But these principles are described in Captain PPT. Conclusion. Books on the art don't promise to make you an artist. All they can do is give you some time, some of the tools, techniques, and thought process that other artists have used. So this book cannot promise to make you a good programmer. It cannot promise you to give codes and all it can do is to show you the thought process of good programmers and the tricks, techniques and tools they use. Just like a book on art. Book will be full of details. There will be a lot of code. You will see good code and you will see bad code. You will see bad code transform into good code. You will see list of hero discipline and technique. You will see example after example. After that, it's up to you. Remember the old joke about the concrete building, boiling? I think joke is messed up.
Violin.
Violin, who got lost on his way to perform. Oh, okay, the one to his performance. He stopped an old man on the corner and asked him to go to the stage show. The old man looked at the violin and then violin tugged under his arm, said, "Practice and practice." Oh, yeah, yeah. So I guess this is it for the how like the first episode. And now suddenly I got it told like this book is paid and like this isn't free and I'm actually showing it on the YouTube. So I don't think that's allowed. So now I understand maybe it could be like a legal problem like I'm showing a copyright content on the YouTube. But I don't know. I will keep this live shown out because this is my first one. If there will be any notice or something like that, I don't know. I know no one will use it. It won't be a problem. But that's kind of a wrong choice. So I can't find a copyright content on YouTube for 3 years like that. So maybe I will think about it. Like I will have to if I want to continue uh, doing this. So the only way is to like upload videos. Yeah, I think. But the videos will also not have book like it will have the code or the summary type. Maybe our summary. You will have to read book to get the complete summary. Can do that, and I can include the coding examples because yeah, you know it can't show the copyright content on the YouTube. But the first chapter was amazing. If you want to buy this book, you can buy, you can study, just yeah, it's all on you. And How was my first live stream? I would love to hear from you in the comment section and hope to see you again. I guess I'm gonna see myself again too. Anyway, I'm just doing it for the fun. So thank you. Thank you for joining me. Bye bye. See you again in the next video live stream. I will think about it.